Okay, AP Physics C. I guess I should take off my mask here. Midterm review. All right, so this video is pretty much just going to be an overview of the main topics, just kind of a reminder to get your brain going. I have a review packet. It's a few pages. I'm going to add one more problem to it to get you going. Now, the midterm is going to consist of 4 questions. All right, 4 problems. You have 1 hour, so that's about 15 minutes each. Some won't take 15 minutes, some will. Now, the time it takes to submit the exam, that's not really factored in. You have to submit it. So it's from 12 to 1, okay? Or sorry, from 11 to 12. I'm expecting the submission on Google Forms no later than about 12:05. So you can't take a bunch more time, but I don't want you worrying about the submission part as part of the time. So 4 questions. All right, so what are they going to be? Well, one of them is going to be kinematics. All right, so the Sharpie's starting not to die, but oh well. Kinematics, so that's the general idea there is you'll get a function of some kind. It may have to do with terminal velocity. It may just be a function, position, velocity, acceleration. Big thing to remember there is it's going to be clearly with calculus, right? So you got to remember that velocity is the derivative of position with respect to time. I'm using x here for position. Acceleration is the derivative of velocity with respect to time. Displacement, delta x, is the integral of a velocity with respect to time. And change in velocity is the integral of acceleration with respect to time. All right, so take a derivative, it brings you down a function. Take the integral, it brings you up. But remember, integral consists of 2 things, the antiderivative and then evaluated over an interval. Usually this is from t1 to t2, t1 to t2, something like that. All right, so kinematics, that's what one of the questions is going to be. Okay, so then from there, we've got multi-dimensional motion, right? We call the MD motion. All right, and really there's a couple things going on here. We've got projectile motion, right? And projectile, the acceleration in the y direction is always 9.8 meters per second squared, negative typically. The magnitude of the acceleration is 9.8. The negative sign depends on how you set up the coordinate system, and the ax equals 0. That's the whole point with projectile motion. It's multidimensional motion in a very specific case. All right? And then also in multidimensional motion, we have the I, J, and K hat stuff, the vector notation, right? Where we, rather than doing component form where we have x direction, y direction, z direction, we do it in this vector form, which you guys kind of liked. At least the kids in school kind of liked it. And the last part of multidimensional motion is rotational. All right, rotational. Oh boy, this kind of need its own area here, right? So rotational is basically all of this, but x becomes theta, v becomes omega, alpha becomes, or a becomes alpha, right? So it's rotational motion. This is, we call this angular position, right? Angular velocity, angular acceleration, right? Or rotational position, velocity, acceleration. Now, a couple things to remember here. When something's moving in a circle, all right, it's got a tangential velocity, all right? It's got an omega, which is rotation rate in radians per second, and it's got a tangential velocity. At any point, its tangential velocity is r omega. Also, its literal linear acceleration at any point, I say tangential, but sometimes it's also called linear, is r times alpha. As long as we're in radians per second and radians per second squared, right? We use radians per second as our unit, and where this is R. So this is rotational. So rotational is pretty much like regular kinematics, but with, with this. All right. Now, one thing I just remembered about kinematics is constant acceleration has special equations, right? So if you know the acceleration is constant, you can use your good old delta x equals 1/2 at squared plus v naught t, and v squared equals v naught squared plus 2a delta x. All right. The basic definitions of velocity and acceleration. Average velocity is delta x over t. Acceleration is delta v over t, right? Those are all for only constant acceleration, right? Constant acceleration. Now, one last thing here. Static forces. All right? So that is, kind of its own thing, right? So I'm not going to talk too much about that, being that we are just doing this. We're just finishing this up. I'm taking quizzes on it. You'll know what that means. So 4 questions. All right. So I have kinematics with Calc. I have constant acceleration. I said projectile motion here. That kind of has overlap with the constant acceleration, right? Usually when we're doing projectile motion, it's constant acceleration, right? So there's some overlap there. I have the IJK notation. I've got rotational and static forces. All right. So I see 1. This is kind of 2, projectile and constant. Static forces is 3. IJK is 4, and rotational is 5. So, I kind of have 5 different areas that we could draw from, but only 4 questions. So, it's a little bit of a guessing game here. What's it going to be? What's it going to be? We'll see. So the general format, all right, of it is going to be kind of what we've been doing with the quizzes, right? Is going to be there's going to be an assessment in my CBA. An assessment in my CBA. All right. It's going to look like a timed quiz, just like what we did at the end of last year when we were in quarantine. I've been using Google Forms this year because it's much easier to deliver nice looking images, and it's much easier for you to upload the work, and it's much easier for me to see the uploaded work and comment on the uploaded work. I will probably annotate your solutions that you upload. All right, so you're going to go My CBA. It's going to be a midterm assignment in there, right? You're going to click it. It's going to give you some instructions, and it's going to bring you to the first question. And basically, the first question is going to have a link to the Google form, all right? Or even the instructions will probably have a link to the Google form. So you're going to go into it, and you're going to go My CBA, the midterm, all right? Then in the midterm, you're going to get knocked out to Google Forms. So make sure you're in Chrome, right? Chrome/CBA account, right? So you can see the problems. I'm just going to list them all at once so you can see them all and decide how to budget your time. You're going to do them on scrap paper, all right? You're going to do them on paper, all right? Do on paper, right? So just make sure you number them. I'm not going to shuffle the order of the questions. Number the work. Okay? Number your work. Show all work. If you want to get partial credit, right? Basically, I make, the questions are probably pretty much 10 points each. Depending on how things go, maybe not exactly. The the raw points don't really matter. I'm just going to scale them to 100 anyways. I haven't sat down and made the key yet. The problems are all pretty much just taken from what I've already given you and just changed around a little bit. Change of numbers, change of direction of forces, that sort of thing. But anyway, you're going to show all your work, number your work, make sure it's easy for me to see. Once the time expires on the quiz, then take your pictures and upload them to the Google form, okay? So that Google form should be coming in within 5 minutes of the ending time of the quiz. And if there's an issue, please email me, all right? Please email me. If there's any issues, I'll be sitting right here in my classroom. I'll have my email open. Please email me immediately. Then you're gonna upload. I will say, if you have Cam Scanner or some way to make it a PDF file, that's a lot easier than individual pictures. But if you have to do individual pictures, that's okay. I prefer a scanned PDF. That's something you should learn how to do anyways this day and age, in this whole digital learning environment. All right, scanned PDF is best, but photo's okay. And this is one of the reasons why we're using Google Forms, is because when it's on my CBA, I was telling my students today, those of you with really nice phones, the preview pane in my CBA is at a full resolution, so I only see like a 1/20th of the paper. So I have to I have to download the images and then view them, and then, it's better in Google Forms because when you put it on Drive, I can add comments to it very easily, so I can give you feedback. And it just works quite a bit better. So make sure you know how to do that. Basically, you're going to have to upload them to Drive from your phone, and then from Drive into the assignment, right? So make sure you know how to do that. If you're not sure how to do any of that, please let me know. All right, so that's it for this. Just again, a very basic overview of the topics. All right, I know it was messy when we looked at it in the end, but hopefully you followed along and have a grasp of the kind of the 5 main areas here. I will say, I think they're all going to be covered one way or another. Maybe you could be clever and think about how I might combine some of these into one question. But guarantee kinematics, static forces, rotational question, right? And then maybe some combination of these, or we'll see. All right? All right. Take it easy. Email me if you have any questions.